and then from the gearbox, the drive is attached to the wheels, and this is how your power transmission happens inside the engine. So then we have the piston rings. So piston is slightly a little loose inside the combustion chambers so that it smoothly transmits the power reciprocates inside the combustion chamber or inside the cylinder. So there are the rings fitted on the piston so that the system is made gas proof or airtight, you can say. So there are several types of piston rings fitted into the slots around the piston, providing a tight seal between the piston and cylinder wall, thus preventing the leakage of the combustion gases. Then we have the gudgeon pin. It forms the link between the small end of the connecting rod and the pistons. So this pin is your gudgeon pin that connects the connecting rod and the piston. Then we have the camshaft. The camshaft and its associated parts control the opening and closing of the inlet and exhaust valves. Then we have cams. So these inlet and exhaust valves are controlled with the camshaft over here and the cams over here. In the next video or animation, I'll show you that. So don't worry. I'm just reading out the definitions as of now. Then I'll locate the part specifically. Then we have the flywheel. So basically inside an engine, the power stroke is not continuous. The power stroke is not in uniform. So there is a power stroke in a stroke, and then there are some strokes that are not producing power. So in order to uniformize the torque that is produced by the engine, we need to have some anything, any rotary mass that has any energy, and when there is no power, it can provide its energy to the system, and it uniformize the system over there. So net torque imparted to the crankshaft during one complete cycle of the operation of the engine fluctuates, causing a change in the angular velocity of the shaft. In order to achieve a uniform torque, an inertia mass in the form of a wheel is attached to the output shaft, and this wheel is called as the flywheel. So basically, the flywheel is something that rotates uselessly during one stroke where the power is basically uh, produced, but in rest of these strokes the power is not produced. So there is a fluctuation in angular velocity that leads into fluctuation of the power, also the fluctuation of the torque also. So in that power stroke, it stores energy inside it as it is rotating with some inertia. And when there is no power stroke, it provides this inertia or this energy that it has stored inside it to the engine, so that in all over the cycle the power is uniform and it is as minimum, the deflection or the fluctuation is as minimum as possible. Then we have the nomenclature. Nomenclature means cylinder bore. The nominal inner diameter of the working cylinder is called the cylinder bore. Just give me a moment. I'll explain that with the help of just a moment. I'm importing an image over here. Just be with me. Okay. All right. So what is cylinder bore? The nominal inner diameter of the working cylinder is called. This is the cylinder, if you can see. So this diameter is your cylinder bore. Then we have the piston area. So this is the piston. This part is your piston. So there is some area of this piston, and when we talk about this area, we are talking about the top of the piston would be something like this, a circular thing. So this diameter, if it is equal to the diameter of the tops of this circle, if we draw it on the piston, so if you see this is the piston front view, right? And this would be the connecting rod. Okay, so you will see that this piston top view can be drawn as this. So this is the diameter, and this area, if we calculate, will be known as the piston area. Then there is a stroke, the nominal distance through which a working piston moves between two successive reversal. So basically stroke. Okay, so if this piston goes over here and over here, so this is your stroke. All right. Then you have the dead center. As I already talked about it, the dead center. There are two dead centers. One is the top dead center, and one is the bottom dead center. Okay. So this position, when the piston comes over here, so this is known as the TDC, or top dead center. When the piston goes the bottommost position, it is known as the BDC, the bottom dead center. I'll again come over the presentation and I'll read out these definitions for you. As of now, I'm just uh, making it easy to you to understand these definitions by just drawing these images. Then we have the swept volume. So when the piston goes from here to here, from TDC to BDC, it sweeps some volume. It takes some volume with it. So that volume is known as the swept volume. Then we have the cubic capacity. So suppose this swept volume is, let's say, 50 cc, and there are four cylinders inside the engine. Then this will be the engine capacity 50 multiplied by 4, and that will be 200 cc. So this is the swept volume. This is the number of cylinder. When you multiply these, this will be giving you the cubic capacity or the engine capacity. Then you have the clearance volume also. The nominal volume of the combustion chamber above the piston when it is at the TDC. So what happens in order to keep the things working fine and good, this part is of the cylinder and this part of the piston actually has some clearance. So when piston reaches the TDC, this is the TDC point. When this piston reaches the TDC, there is some space left blank. If you can see over here, this space, this clearance, this volume is known as the clearance volume. And then there is a compression ratio. The compression ratio, the total cylinder volume when piston is at BDC to the clearance volume, is known as the compression ratio. Okay, I'll read out the definitions again. Cylinder bore, the nominal inner diameter of the working cylinder is called the cylinder bore. Then you have the piston area, the area of a circle of the diameter equal to the cylinder bore or equal to the piston area. I mean the top view, you will have the piston to be a circular thing. that is known as the piston area. Then stroke, the nominal distance through which a working piston moves between two successive reversal of its direction of motion is called the stroke. Then you have the stroke to bore ratio. Stroke to bore ratio, the cylinder bore and stroke ratio. This is known as the stroke to bore ratio. Then there is dead center, the position of the working piston and the moving parts which are mechanically connected to it at the moment when the direction of piston is reversed at either end of the stroke is called the dead center. There are two dead centers. The top dead center when the piston is the farthest from the crankshaft. It is at the most farthest position from the crankshaft. It is known as the top dead center or TDC. And when the piston is the nearest to the crankshaft, this is known as the BDC or bottom dead center. Then there was a swept volume, the nominal volume swept by the working piston when traveling from TDC to BDC. Then there is cubic capacity, the swept volume of the cylinder multiplied by the number of cylinders in an engine is the cubic capacity. Then clearance volume. So always at the topmost position of the combustion chamber, the piston doesn't hit the topmost position. It has some gap, and that clearance or gap is known as the volume of that gap or clearance is known as the clearance volume. And then the compression ratio. The compression ratio of the total cylinder volume when the piston is at BT bottom dead center to the clearance volume. So this is known as, this is a mistake from my end. This is BDC. So this is known as the compression ratio. Then four stroke and two strokes and rest of the part we will be discussing in the